and welcome to Arcs and Sectors with Cubit Education. In this lecture, you will know what an arc and a sector is, you will find the length of an arc, you will calculate the area of a sector and tackle some exam problems. So first of all, arc length. So normally when we work out the length of the entire circle, that's the circumference. So instead we want to work out the length of this section or any other arc that they give us in the exam. So first of all, we need to know what fraction of the circle is being shown by this sector. Well, we know that the fraction is 30 out of a total of 360. To calculate the length of an arc or area of a sector, we need to know the fraction every time. An arc is a fraction of the circumference. We get this fraction from the angle at the centre. So, in order to work out the arc length, we must take the value of the angle at the centre, okay, and we need to divide that by 360. We then need to times it by 2 pi r. The reason we need to times it by 2 pi r is because 2 pi r is what we would use to find the circumference in total. You can either use 2 pi r or pi d. So let's have a look at an example. Here we have a circle with an arc length here and an angle at the centre of 30 degrees and a radius of 18. So this is the formula that we need to use. So we just need to input all of our information. So 30 would go there because that's the angle at the centre, divided by 360 times by 2 times by pi times by r, which is 18, as it tells us here. So all we need to do now is work that out. So if you can put that in your calculator if you like, or you can do 2 times 18, which is 36, okay, and you can cancel down this fraction to 1/12 just to make it a little bit simpler. We can then just do everything on our calculator like that. It leaves us with 3 pi, or if you press the SD button on your calculator, it will give it you as a decimal. So the arc length would be 9.42 centimetres to 2 decimal places. Let's have a look at the area of a sector then now, and then we'll do some more examples. So to work out the area of a sector, this is the formula that you must use. It's the angle at the centre divided by 360, because that's the fraction that we need, times by pi r squared. We need to use pi r squared because that's how we would find the area of the entire circle, and what we're doing here is just finding a fraction of it. So here we have the same circle, but we're going to use our formula for the area instead. So where the theta sign is, which is this, would be 30 times by pi times by r squared, which is 18 squared, because 18 is the radius. So then I've just cancelled down my fraction to 1/12 just by taking off the zeros and then dividing it down. And then I've done this 18 squared, we're giving us 324, and then we just still need to times it all together. So if we times it all together, your calculator will end up saying 27 pi, but as before, if you press the SD button, you will get an actual number, which is 84.82 centimetres squared to 2 decimal places. Okay, so let's have a look at calculating the length of the arc and the area of a sector if we don't know other values. So for this question, it's asking you to find the radius of this sector, giving your answer to 1 decimal place. So what you do know here is you know the angle at the centre, and you know that the area of this section here, okay, this sector rather, is 80 centimetres squared. Now it's asking us to find the radius, so we're going to use the formula for the area of the sector. Okay, whichever formula you use, it must have pi in it, and we just input the information we have here. So 125 would go on top out of 360 in total, times by pi times by r squared. Well, we don't know r, so we can't put that in. Now we can divide both sides by 125 over 360, which means then that we would end up with pi r squared on this side of the equals, and this one would move over here because we've done the opposite. So we end up with 80 divided by 125 over 360. We end up with pi r squared equals 230.4. Now we still need to get this r squared on its own, so we actually need to divide by pi. If we divide by pi, it moves the pi from this side of the equal sign to this side, because don't forget we're doing the opposite. Now if you're struggling with this, please go back and watch the video on rearranging equations, because that's what you need to know in order to be able to do this. So we're going to divide by pi, leaving us with r squared equals 73.339. So as we divide by pi, it moves it from there to this side, and we actually divide this on our calculators by pi. We're then left with r squared on its own equals 73.339. Now the last thing we need to do, because we don't want r squared, we just want r, so we need to square root. So the square root of 73.339 is 8.6 centimetres. So our radius must be 8.6 centimetres to 1 decimal place. Okay, so calculate the angle at the centre of this sector, give your answer to 1 decimal place. So in this instance, we're going to use the length of the arc formula. Okay, so that means we need to use our angle at the centre, which we don't know, divided by 360 times by 2 pi r. So if we wrote that out again, but we can't put our angle in, we'd end up with 2 times by pi times by 8.5, which is here. Okay, and that would give us an answer of 12, because our length of our arc is 12. It's telling us that already. We've got to try and find out the angle here. So what we need to do now then is start moving some things over away from this section here. So what I've done here now is times 2 by 8.5, just to shorten it down a little bit, giving us 17 pi. And then I'm going to divide by 17 pi, because I want to get this on its own. So that now leaves me with theta over 360. And what you would have done is, because you've divided by this, on your calculator you would have actually done 12 divided by 17 pi. So now it gives us this decimal answer. The final thing we have to do is times by 360, because we need to get theta. So 0.2246 times 360 gives us 80.9 degrees for the angle at the centre. Okay, so what about this one then? Calculate the angle at the centre of this sector. Give your answer to 1 decimal place. If you would like to have a go at this one, please feel free to pause the video and then press play for the answer. Okay, so for this one we're going to use the area of the sector formula. It doesn't really matter which one you use, as long as you manage to work out this. So what we're going to do is put our information in. Now we don't know theta, but we do know that r is 9, so we can put 9 in there, as it says here. And we know that the area of our sector is 125. Now obviously for the previous one, we had to use the length of the arc, because that's what information they gave us here. So in this case, even though you could use any of them, depending on which information you are given, it's giving us the area, which means we have to use the formula for it. So think about what you know and what you're being told. So now I'm just going to square 9 to get it on its own a bit simpler, giving us 81 pi. And then all I'm going to do is divide by 81 pi. So 125 divided by 81 pi gives us 0.4912. And now for the final thing is to times by 360 to get theta, which is 176.8 degrees to 1 decimal place. Okay, so the final question that we're going to look at then in this lecture is calculating the length of the arc of the major sector. So I want you to pause the video and have a go at calculating the arc of the major sector, and then press play for the answer. Okay, if you've had a go, let's have a look. Now the first thing we need to do is work out the radius, because we don't actually know that. So we're going to look at the area of the sector formula, and we're going to put in the information that we've been given. Now it wants the area of the major sector, which means we need to know this angle here. So 360 take away 27 degrees gives us 333. So that's this major segment here. Okay. To be fair, to find the radius, it doesn't really matter just yet. But anyway. So now I'm going to divide by 333 over 360. Okay, the reason for that is I'm trying to get this r value on its own. If I divide by that, I can move it over here out of the way. I can then do this bit on my calculator. So pi r squared is 276.756756 and so on. So now I can divide by pi. If I divide by pi, it leaves me with r squared, which is 88.0944. And finally, to get r all on its own, I need to square root. So that means that r is 9.386 centimetres to 1 decimal place. Now that we've figured out what r is, sorry about that, my mistake. If you need to get those down as extra notes, please do so. Okay, so now that we know what r is, we can actually work out the arc length of the major sector. So we need to take our 333 degrees over 360, and because we're doing arc length, remember, we must use this formula. So I'm going to times that by 2, times by pi, times by our new r value, which we figured out here. Okay, so if you then just put all of that in your calculator, you end up with an arc length of 54.55 metres to 2 decimal places. Okay, so that was quite a tricky video and there was a lot of information in there. Hopefully you know what an arc and a sector is now, and you can find the length of an arc and calculate the area of a sector. Those questions that we went through were exam questions, and I hope you feel a little bit more confident. Please comment on the video if there are some other things you would like me to add. I do plan on doing some videos where I go through an entire kind of workbook on circles, arc length, sectors, finding the circumference and finding the area. But if there's anything else specifically that you want to see, please comment and let me know. Okay, so well done and thank you so much for using Cube Education, and I hope to see you next time.